In this video, we're going to be evaluating each of these logarithms without a calculator, and then we're going to do another set of examples where we're going to use a calculator to evaluate our log functions. So in this first set, we have the log of base 2 of x, where x equals 16, and we're going to evaluate this without a calculator. So it's helpful to think in this one, how would I write that as an exponential function? So we want to find our base, because it's all about that base, So we have a base of 2. So, well, maybe let's rewrite this first. Let's see what this looks like with those 16. So what we're really looking at here is the log base 2 of 16, and it wants to know, what does that equal? So now let's go to our, so again, we know our base is a 2, and remember that it's all about that base, So it's going to go 2. Now normally we would go to the window and then back to the wall, right? So equals 16. So we want to know 2 to what power is 16? So to evaluate this, all we need to do is go, gosh, what should go in that question mark's place? So 2 to what power is 16? And the answer to that question is 4. So our solution is 4. Let's take a look at this next example. Here we have a log base 12 of x, where x equals 12. So we'll rewrite that as the log base 12 of 12. We're going to find our base because it's all about that base, So we find our base of 12, and then we're going to go to the window over here, right? Which remember, we don't know what that is. So 12 to what power equals, and let's bring it back to the wall, 12. So 12 to what power is 12? And that answer is a 1, an exponent of 1. So when we evaluate this, the log base 12 of 12 is 1. Let's take a look at letter C. So here we have a log of base 1/4 of x, where x equals 4. So let's rewrite that as the log base of 1/4 of 4, and we don't know what that equals, so we're trying to figure that out. And now we're going to find our base because it's all about that base, So we have a base of 1/4. So we have 1/4, and then we're going to bring on over to the window. So 1/4 to what power equals, then bring it back to the wall. So 1/4 to what power is 4? Because we're going from a fraction to a whole number, that tells us that our number is going to be a negative. Likewise, if this was a whole number and we were going to a fraction here, then our number would also be a negative. So whenever you have a switch happening, your number, your exponent, will be a negative. So because our denominator is a 4 and this number is a 4, that tells us that our number is going to be a 1. So we know that it's going to be a negative because we're going from a fraction to a whole number, and we take a look at our denominator, and to get a 4 to turn into a 4, you need an exponent of a 1. So here we have negative 1. Go ahead and try letter D on your own. So push pause, and then when you're done, push play, and let's see if you were right. So here we have the log base 4 of x, where x equals 1. So we're going to go ahead and rewrite that as the log base 4 of 1, and we want to know what that equals. So we're going to find our base because it's all about that base, So we've got our base of 4, then we're going to go to the window, and then back to the wall. So 4 to the what is going to equal a 1. So 4 to what power is a 1? What exponent would give us a 1 there? That's right, a 0, because anything to the 0 power is 1. So that's how you can evaluate logarithms without using a calculator. So now let's go ahead and let's do this next set of examples where we're going to use a calculator to evaluate these. So at each of these, we're going to have the log of x, where x is each of these values. So what that tells us is that we'll be looking for the log of 10, the log of 1/3, the log of 2.5, and the log of -2. notice that it didn't actually write the base down. And the reason it doesn't have a base is because it's the common log, which means it has a base of 10, and we don't need to write that. And our calculator will do a base of 10. So we're going to go ahead and plug these into our calculator and then round them to 3 decimal places. So we're going to go ahead and plug this in. We're going to use our log button that's right here. So we say the log of 10 and then hit enter. And the log of 10 is a 1. So we don't really have anything to round there. So go ahead and put a, and now we'll go ahead and we'll do our log of 1/3. So our log of, put in our fraction of 1/3. And that's going to give us an answer of negative 0.47712. Remember, we're rounding to 3 decimal places, so negative 0.477. So we'll go ahead and we'll write that down as our answer. So that's our answer. So I'm going to have you go ahead and do C and D on your own. So I want you to go ahead and push pause, plug those into your calculator, write down your answers, and when you're done, push play, and let's see if you're right. So when we plug in the log of 2.5, we get 0.39794, which will round to 0.398. When we take the log of negative 2, something interesting happens. We end up getting an error message. In this case, there is no real power to which 10 can be raised to obtain a negative 2. So here we'll have no real solution. And so that is how you evaluate a logarithm without a calculator and with a calculator.